I wanted to talk to you guys a little bit about the idea of spread and the fact that we have explored a lot of different measures of spread. And sometimes we don't know which one we use. Sometimes we talked a lot about which measure of central tendency to use when, and we really didn't talk about any of the limitations of some of the measures of spread. We didn't talk about resistance in terms of measures of spread, so let's just break this down as quickly as we possibly can before it turns into some sort of rant about spread, because I honestly could go on probably for 20 minutes. So let's just think about the spread that we have learned about in this course so far. So range, IQR, interquartile range, and standard deviation and variance. Let's go in order. Range, IQR, variance, standard deviation. Those are pretty much the main four measures of spread that we examine in this course. So range, awesome, tells you how physically spread out a graph is, a distribution, right? You have the minimum and maximum, and then you see, is the graph like really squished on the number line? Is it spread out on the number line? Okay, so if you only had the range, you could compare ranges, and then you could talk about the data being spread out that way. The limitation with range is that you only take into consideration the extreme values. What if you had one or two outliers? What if your minimum is an outlier? What if your maximum is an outlier? What if they're both outliers? It literally tells you nothing else about the data. All right, range. I'd prefer not to use it if I didn't have to. That's why we teach it to you first as a very youngin. Next, interquartile range. Interquartile range it solves that problem of range, right? So interquartile range, instead of taking into consideration just the two endpoints, we're taking into consideration the middle 50% of the data. So you're like, all right, so let's look at what's the measure of central tendency and what's the measure of spread. Let's look at IQR, because IQR is not gonna be skewed by the outliers. It doesn't even look at the outliers. It looks at everything between quartile 1 and quartile 3, and that's it. Which is cool. That's great. Fine. Okay, I think it's better. So you got range. IQR is a little bit better because it like looks at 50% of the data. Range literally looks at 2 data values. Doesn't help us in the long term. IQR looks at the middle 50% of the data, so it is a little bit more holistic. However, now the problem with range was that we looked at the outliers too closely, and the problem with IQR is that we don't look at the outliers at all. We only look at the middle 50% of the data. So if you have an outlier, you're not going to know. So range is not resistant to outliers, but also doesn't look at the rest of the set. Okay, so range could reveal outlier behavior. No, it doesn't. It can't, right? So it not if you didn't have the rest of the data to look at, right? So the range only takes into consideration outliers. We have no idea if they're, even if we're just given the range, you have no idea if there's outliers or not. Okay, IQR, awesome. You could see the bulk of the data, the middle 50% of the data. Nothing too high, nothing too low, whatever. But we want to know if there's outliers because we want to know how varied our data set is. And that brings us to variance. So we go through all this. Instead of looking at the range or the IQR, we look at each and every single deviation of each and every element of the set, right? And we do that, we do all this work, and there's a formula, and it's wonderful, and it's great. The only issue with variance is that it's not in the same unit as when you started. So let's say that you're measuring wildflowers because you're doing some sort of project, or an environmentalist is doing this. They're measuring in millimeters, and you go through the whole formula. You take all the deviations, and then you square all the deviations. As soon as you square all the deviations, now your variance is actually in millimeters squared, which is fine, okay, because you would know that. You would know that going in. If I said, okay, the variance, so I said, okay, the mean height of wildflowers is 25 centimeters right now, and the variance is 13 centimeters, 12 centimeters squared. Oh, millimeters. Whatever unit I'm using. I think I started with millimeters. Let me start over. Okay, so you report a mean, you report a standard, you report a variance, but you're reporting the mean in millimeters and you're reporting the variance in millimeters squared. That doesn't make sense. Okay, so the very last thing that we're going to learn in this class is actually the best thing, and so the last measure of spread is standard deviation. And when you have variance, you square root variance to get standard deviation. So what happens when you take millimeters squared and you square root it? It becomes millimeters. So now, not only are you reporting a measure of central tendency, so let's say you give the mean in millimeters, and then you give a standard deviation, that is also in millimeters. So not only, so standard deviation is like it, okay? Because not only does it look at every element in the set, it is going to show you outlier behavior very easily without compromising what the rest of the data contributes to the variation, okay? And you're reporting the unit, you're reporting the number in the same unit as the measure of central tendency, so it's a little bit easier to compare. Numerically, it is easier for our brains to compare when you're comparing millimeters to millimeters instead of millimeters to squared millimeters. So it's a very small thing, and I know that it might seem like it doesn't matter, but it totally does matter. Summary, because I did really rant, it's been 6.5 minutes. Okay, range has limitations because it only takes into consideration 2 elements, and those 2 elements could be outliers. IQR doesn't take into consideration outliers, but it does take into consideration the middle 50% of the data. Cool. All right. Better, but not telling us about outlier behavior. Okay. Variance and standard deviation both are very good at showing us outlier behavior, so they're not resistant to outliers. So if you have a larger standard deviation or variance, you know there's outliers. And they both take into consideration every element of the data and how each element contributes to the variation or the variability of a set. However, that next step up, so you got range, you got IQR, you got variance. Variance is pretty good, but standard deviation beats it by like a little bit because standard deviation provides the correct unit and it makes it a little easier to compare, analyze, make decisions, etc.